Hey everyone, so we're supposed to have, now that we've come to the end of our Graphing Basics unit, we're supposed to have a big summative assessment, a big quiz, 50 points. And so I want to do a review for that quiz. I don't actually know at the time of this filming how you'll take that test, how you'll take that quiz. And so more on that later. But I do know that you need a review. So I've got a review for you to go along with the review worksheet you're going to do for homework with assignment number 11. Okay, let's start. Our bell work today is all about domain. Yep, I'm going right for the jugular. I want to know the domain in each case. Okay, so first case is square root 3x minus 2. Second case is 1 over 3x minus 2. Third case is cube root of 3x minus 2. And the fourth case is 1 over the square root of 3x minus 2. All right, why don't you pause that video and give these a try. Remember, write your answer in interval notation. Okay, so the first one, I know I have to set the stuff under the radical. I have to set the radicand greater than or equal to 0. So x is greater than or equal to 2/3. Using interval notation, we would write 2/3 to infinity. And you know, if that's hard for you to get to, it might be worth your time to go by way of the number line. X can equal 2/3, closed circle, x is bigger than 2/3. Or test a value like 1 and 0 in this inequality. If I plug in a 1, I get 3 minus 2 is 1. Is 1 bigger than 1? Yes. I'm sorry, bigger than 0? Yes, it is. If I plug in a 0, though, I have negative 2 greater than or equal to 0. No, that's not true. So here's my solution, my domain, from 2/3 to infinity. Okay, next, what can't we have in a denominator? We can't have 0. So 3x minus 2 can't equal 0, which means x can't be 2/3. If I think about this on a number line, there's 2/3. I can't be that, but I can be all these numbers, and I can be all these numbers. And so my interval notation for domain would be negative infinity to 2/3, parenthesis, union, 2/3 to infinity. Okay? What about this cube root? Well, that's a trick question because remember, I can plug any number in there. There's no restriction on cube root of x. So its domain is negative infinity to infinity, just like a polynomial function. Now this one has two restrictions. The denominator can't equal 0, and the stuff under the radical has to be greater than or equal to 0. So let's see how we would approach this. I would say 3x minus 2 greater than or equal to 0, but I would also say 3x minus 2 can't equal 0. So I know x can't be 2/3. So here I get x is greater than or equal to 2/3, but over here it says x can't be 2/3. So even though this is okay with being 2/3, this one says no, not. And so we're not going to be. And so we're just going to say, okay, 2/3 with an open circle and the x values that are larger. So what would that be in interval notation? That would be parentheses 2/3 to infinity. Okie doke. So there's a nice little bell work warm-up for you. But let's take this and make it a little more pre-cal-like. Y equals 1 over x minus a, where a is some constant. A is a constant. Do not put a number in for a. Do not make up a number and plug it in for a. Your answer has to have an a in it. Simple as that. So we know that x minus a can't equal 0. And when we add a to both sides, we get x can't equal a. On a number line, there's a, can't equal it, can be these, can be these. So my domain will be negative infinity to a, parenthesis because we're not included, union a to infinity. See, that wasn't so bad. Don't freak out because there's an a present in the problem, but don't make up a number because this shouldn't have numbers in it. All right. So how about this one? What can you do with this? Square root of x minus a. Please find the domain for this function. Okay? Remember, your domain should have an a in it. Welcome back. So I know that x minus a has to be greater than or equal to 0. And so x is greater than or equal to a. On a number line, equal to a or greater than a. And with interval notation, my domain would be bracket a to infinity. Okay? Let's keep going. I got a few more of these. How about y equals 1 over 2x plus b? Please tell me the domain here. Strongly recommend you try it out, because if the first time you do this is on the big quiz, you're probably going to get it wrong, because you won't be thinking in terms of a, b. That's right, a and b. So we've got 2x plus b can't equal 0, because remember, it's in the denominator, and denominators can't equal 0. I'll subtract b from both sides. I'll have 2x can't equal negative b. Divide by 2. X can't equal negative b over 2. Mr. Kuka, I don't know where negative b over 2 is. Sure you do. Look, it's right there. It's the only thing for my number line. And that's what we can't equal, which means we can equal all these numbers, and we can equal all these numbers. And so my domain is going to be negative infinity to negative b over 2, union negative b over 2 to infinity. Okey-doke. All right. One more. How about y equals the square root of b minus x? Give that one a try. Welcome back. If you have this, so close, but not right. Remember, this is the same as negative x plus b. I'm shifting the graph left b places, but then I'm reflecting it across the y-axis. So this graph looks like that. Not b to infinity, but b to negative infinity. Mr. Google, how was I supposed to know that? Well, you know, we set what's under the radical. We set the radicand greater than or equal to 0. And so now I have b is greater than or equal to x. Or if I read it this way, x is less than or equal to b. Or equal to or less than. So my domain in interval notation will be negative infinity to b with a bracket. All right, how about one challenge problem? Something this hard might not be on our test because it's so challenging. Why don't you give this one a try and determine the domain of this, and come back when you want to check your answer or if you need help. So we know that x squared minus c squared can't equal 0, which means x squared can't equal c squared. Now, what is it that I'm supposed to remember when I take the square root of both sides of the equation? That's right, I'm supposed to remember the plus and minus. So I know x can't equal c or negative c. Okay, negative c, positive c. Now I have these three intervals. and I'm not sure how to test them. Okay, so what can I do? Uh, well, I could say x can't be these numbers, but it can be all the others. See, I don't really have to test the intervals here. But if I wanted to test the intervals, I might try using 0, I might try using 2c, and negative 2c. If I plug a 0 in for x, I get 1 over negative c squared. That's not imaginary, that's a yes. If I plug in 2c, 2c times 2c is 4c squared. 4c squared minus 1c squared is 3c squared. 1 over 3c squared, yep, that works. And the same thing will happen here with negative 2 because squaring will still give me positive 4c squared. So then my domain here is going to come in 3 pieces, negative infinity to negative c, union negative c to c, union c to infinity. Okay? Remember, when you have 2 critical numbers, you've got 3 intervals there. All right, well, message me if you need more help or practice with domain, and I can certainly do that with you. Next, I've got some symmetry questions. Here's the first one. I've given you part of a graph. This is 3, 0. This is 1, 0. This is 2, 1. And this is 0, negative 1. And I'd like you to complete this graph as though this were an even function. Even function. Remember, an even function has y-axis symmetry. We said before we would have to change, because it has y-axis symmetry, we would have to change the sign on all the x's. Negative 1, 0, up here at negative 2, 1, and then back down here at negative 3, 0. So my graph will reflect across the y-axis, okay? Remember, an even function has y-axis symmetry. Hey, so what would it look like if instead I had asked for an odd function? Remember, an odd function has origin symmetry. And with origin symmetry, we said we needed to change both the x's and the y's. So this point will become 0, positive 1. This point will become negative 1, 0. This point, when I change both signs, is negative 2, negative 1. And this one, I change both signs and I end up with negative 3. So, concave down because this is concave up, and then concave up because this is concave down. And there I have my odd function with its origin symmetry, okay? Why don't you try completing this graph (0, 2, 1, 0, and 2, 1. Please complete this graph. I've given you part of f of x. F of x is the whole picture, but right now you're only looking at part of it. Will you please complete the graph as though f of x is even? That's right, an even function has y-axis symmetry, and we know with y-axis symmetry we change signs on x's. So this becomes negative 1, 0, and this becomes negative 2, 1. Okay? And so we're just reflecting across the y-axis, so this concave down matches this concave down, and this concave down needs to match this concave down. Good. Oh, did I say even? Oh, I'm sorry. I really meant to say odd. how do I draw this, complete this graph if f of x is odd? Will you give that a try? Okay, so an odd function has origin symmetry, and we know that means that every xy pair becomes a negative x, negative y. I need to change the signs on both the x's and the y's. So this point 0, 2 is going to be 0, negative 2. This point 1, 0 is going to be negative 1, 0. And this point 2, 1 is going to be negative 2, negative 1. Okay? And I've got that and that. Excellent. How did I know it should have this shape instead of this shape? I knew because origin symmetry reflects through the origin. So this point is coming down here, and this point is coming down here. And so these look like mirror images of each other, which they wouldn't if I had concave down here. I need concave up. All right, so no problem with symmetry. No problem. Oh, yeah, no problem with symmetry. I don't know, should we do an x-axis symmetry? Let's go back to that last one. 0, 2, 1, 0, and 2, 1. Will you please finish the graph of f of x? If you knew, oh, it can't be f of x, can it? Can you finish this graph so it has x-axis symmetry, reflecting across the x-axis? And then tell me why it is that I had to erase f of x so quickly. Okay, so we know with x-axis symmetry, the x's don't change, but the y's change. So this is 0, negative 2. No change in this point because the y's don't change there. And when I change this one, I have 2, negative 1. Okay, and so whoop and whoop. I am reflecting across the x-axis. Why is it that I can't call this a function? Because it fails the vertical line test. We said anything with x-axis symmetry is not going to be a function. So this is not a function, which is why I said so it has x-axis symmetry. Okie doke. Now let's talk about minimums, maximums, increasing and decreasing. I've got two problems here for you. Here's the first one. Here's 0, 1, 4, 0, 0, 4, negative 1, and 6, 0. Okay, so here's f of x. And will you please tell me where f of x is increasing? Let's start with that. Where is f of x increasing? Okay, so will I write 0, 0, 2, 1, 4? Not unless I want to get the problem wrong. Remember, when we talk about increasing and decreasing, it's always in terms of domain. It's always in terms of x values only. So we might think to use this x value and this x value, and this x value and this x value. Would that be correct? No, I'd have to mark that wrong too. Oh my goodness, how come? Well, is the function increasing before we get to x equals 0? Sure, we're going up here. Is the function increasing after 6? Sure, we're going up for x values bigger than 6. So our domain needs to be, or when is f increasing, that region would be negative infinity to 0, no, to 1, because I'm looking for this whole positive slope thing, union 4 to infinity. Remember, these aren't y values, these are x values. As I go this way forever, the function is going to always be increasing. Okay? So there's increasing. Why don't you try decreasing now? That's right, decreasing is much easier. We're just going from here to here. Remember not to use ordered pairs. I know you're probably saying, you keep saying ordered pairs. I heard you already. But on the quiz, people are going to be listing ordered pairs because they're not paying attention. Write it down in your notebook. Yeah, 1 to 4. Okey-doke. Now, what about max? What about min? Well, these go forever, so the endpoints don't exist. So there's no maxes and mins here, but there is a max on the graph, and the max of 4 at x equals 1 because f of x goes from increasing to decreasing at x equals 1. And we have a min at x equals 4 because, oh, and I guess I could say a min of -1 at x equals 4 because f goes from decreasing to increasing. Okay, I need to be able to identify maxes and mins. I need to be able to talk about increasing and decreasing correctly using interval notation. I'd like to have the same 4 questions answered, increasing, decreasing, maxes, and mins, for this function. Y equals -x to the 4th plus 4x squared minus 3x plus 12. Okay, now, you may be someone who is wicked comfortable factoring this and graphing this, but many students in class will not be. We have not reviewed factoring, we have not reviewed graphing polynomials like this, so my expectation is that you're actually doing this problem with a calculator. Okay, with a calculator. So with a calculator, I want to turn it on. I want to go to y equals, and I want to type in, remember to use the negative and not the subtraction symbol, negative x to the 4th plus 4x squared, oops, x squared, yes, minus 3x plus 12. Okay, and I'll start with this as standard window, so I did zoom standard. Huh, is that all there is? I feel like I'm missing stuff. Okay, well, I'm definitely missing some stuff up there. So I think I want to move the y max higher. Let's try 50 in steps of 10. Oh, whoa, look at that. So I didn't need to go all the way to 50. Probably 30 would be enough. Graph. Okay, so I see here a max because the function goes from increasing to decreasing. And I'm not sure, but I think I see a minimum here where the function goes from decreasing to increasing. And then I see another max over here where the function goes from increasing to decreasing. And let's put that under the light. I think light would be better. Yes. So here's a max where we go from increasing to decreasing. This appears to be a min where we go from decreasing to increasing. And there's another max where we go from increasing to decreasing. That's going to be hard for me to see with this viewing window, and I don't need this stuff over here, so I think I'm going to change my x values in my window to go from -3 to 3. Okay? Okay, I have a much better sense of what's going on. So if I want to talk about a max, I need to find that maximum and that maximum. Second, calculate max. I move my cursor to the left side of the max and hit enter. I move my cursor back to the, oops, see, I wasn't on the left side of the max. Oh well, try again. Second, calculate maximum. Okay, here we go. We're going to the left side. Slowly chugging our way over there. Okay, I believe I'm on the left side of the maximum. I hit enter. I go over to the right side of the maximum. I hit enter. Do I want to guess? No, I hit enter. And I get negative 1.573. Well, negative 1.574 because we round to 3 decimal places. And there's the second max over here that I need to find. Second, calculate max. I want to be to the left side of that maximum. So I'm going there. And now I want to go to the right side of that maximum. So I want to be here, no guess, and I get 1.164. Okay, now what about that min in between them? Second, calculate minimum. I want to be to the left side of the minimum. Not sure where it is, so I'm going to go way back here and hit enter. And then I'm going to go way over here and hit enter. And I don't want to guess. I hit enter again. My minimum appears to be at 0.409. Okay? Now, what about increasing and decreasing? Well, this function is increasing from negative infinity all the way up to that x value. That x value is here. So I want negative infinity to negative 1.574. But this function is also increasing from here to here, from the minimum to this maximum, from this minimum to this maximum. So then I'm going to have 0.409, comma 1.164. That's when the function is increasing. What about the function decreasing? Well, this function is going to be decreasing any place it's not increasing. So I'm going to be decreasing from negative 1.574 to 0.409. And after this point, after the maximum, from 1.164 to infinity. Okay, so we should be able to do this stuff by looking at a graph, whether we have to make that graph and do those things on our calculator, or the graph is presented to us. All right, next. What's average rate of change? Remember, average rate of change is slope with units, okay? So, let's say I have S of t. This is position in feet as a function of time in seconds. And I'd like to know the average rate of change on 1 to 2. Please find the average rate of change on 1 to 2 given, let's have an S of t here, given 3t squared minus 2t plus 1. And again, that interval was 1 to 2. How do I find average rate of change here? Remember, average rate of change is slope with units. And in order to find a slope, I need 2 ordered pairs. Well, right now, all I have are 2 x values. I need 2 ordered pairs. How do I get these y's? Well, I have to take this x and plug it in here. So 3 minus 2 is 1, plus 1 is 2. Now this is really spooky. This is an ordered pair, but this is not an ordered pair. This is an interval. This is a domain. If I plug a 2 in here, 2 squared is 4, times 3 is 12, 2 times 2 is 4, 12 minus 4 is 8, plus 1 is 9. So now I have my two ordered pairs. I had to plug these endpoints in order to get the ordered pairs. Now I can use my slope formula and say average rate of change equals 9 minus 2 over 2 minus 1. Remember, the outputs were feet and the inputs were seconds. So these are feet and these are seconds. And I end up with 7 feet per second. Okay? What if we used an interval of -1 to 3? So I still need to do the same thing. I need to find s of 3. I need to find s of -1. That's 3 times 3 squared minus 2 times 3 plus 1. 27 minus 6 is 21, plus 1 is 22. So I know I have the ordered pair 3, 22. And if I plug in a -1, -1 times -1 is 1, 1 times 3 is 3, -1 times -2 is 2, so 3 plus 2 is 5, plus 1 is 6. So -1, 6. Well, okay, we're not done yet though, right? Because average rate of change is a slope. I need to plug in these ordered pairs into the slope formula. 22 minus 6 over 3 minus a minus 1. So I get 16 over 4, which is 4. Don't forget, the units on top are the outputs. Those are feet. The units on the bottom are time in seconds. So this is 4 feet per second. Average rate of change is slope with units. Okay, let's go back to the first day. Can you write the equation of the line that passes through 3, 4 and -4, 8? Okay, why don't you try doing that? Please write the equation of the line, and I didn't say whether you had to use point-slope form or slope-intercept. I didn't say whether the answer had to be in standard form or slope-intercept form. I'm just asking you to write the equation of the line so you can use whatever you prefer. Though I do need you to show work for credit. Okay. Welcome back. The first thing I need is a slope. 8 minus 4 over -4 minus 3. I get 4 over -7, or -4 sevenths. Okay? Now I want to write the equation of the line. So I'm going to have y minus y1 equals mx minus x1. And I'm going to plug in this for x1, y1. You could, of course, plug these in, but I chose those. And don't forget to plug in your slope. So y minus 4 equals -4 sevenths, x minus 3. A common mistake is people put a 3 there and a 4 there because the 3 came first as they read across. No, these are y values. I need that y value. Okay, so y minus 4 equals -4 sevenths x. Negative times negative is plus 12 sevenths. And then I think I'll add 4 to both sides. How many sevenths is that? That is 28 sevenths plus 12 sevenths is going to be 40 sevenths. So y equals -4 sevenths x plus 40 over 7. If you needed to write that in standard form, remember, we need the x's and y's on the same side. 4 sevenths x plus y equals 40 sevenths. It's okay not to multiply everywhere by 7. I'm fine with this being standard form. If you did, however, want to do old school standard form, you'd multiply everywhere by 7. And so you'd end up with 4x plus 7y equals 40. And you know, the reason old school liked this so much is because they don't have to look at any fractions. Ew, fractions. No fractions here. Okay, so you should be able to write the equation of a line given 2 points. What about these 2 points? Can you write the equation of the line through these 2 points? Why don't you give that a try and come back when you're done? Okay, well, here's what I notice. 2 minus 2 over 5 minus 0 is 0 over 5. 0 over 5 is 0. What's a zero slope look like? It looks like a horizontal line. Wow, that was surprising. But everyone's okay. So how do I write the equation of a horizontal line? Well, we said y equals a number is the equation of the horizontal line. Our line passes through 0, 2, and 5, 2. And what's our y value? It's 2. So the equation of this line is y equals 2. What if instead I had these points, 2, 0, and 2, 5? How would I write the equation of that line? Well, when I try using the slope, 5 minus 0 over 2 minus 2, I get 5 over 0, and I know that's undefined. How do I write the equation of a line that has an undefined slope? Well, I know if I plot these points, I get 2, 5, and 2, 0. I have a vertical line. And we said the equation of a vertical line would be x equals some number. Which x? The x value that they both have. So this is x equals 2. Okay? Excellent. So we've written the equation of lines. Hey, how about parallel and perpendicular lines? Woohoo! Write the equation of the line parallel to the line through 3, 4, negative 4, 8, but that passes through the point 5, 10. Okay, so when I think about this, there's a lot of words. I have to write the equation of a line. That line should be parallel to some other line. Which other line? The line through these 2 points. So let's start by writing the equation of a line through these 2 points. We know, in order to write the equation of a line, that we need a slope. And there's that 4 over negative 7 again. And we need to write the equation of a line. So y minus 3 equals negative 4/7 x minus 4. X minus, no, I did it, didn't I? I did exactly that mistake. I put the x value there and the y value there. See, people do that. Okay, and so then I have y equals negative 4/7 x plus 40/7. So I want the equation of the line, I'm supposed to write the equation of the line that's parallel to this line, but this parallel line has to pass through this ordered pair. So what do we remember about the slopes of parallel lines? Our slope is negative 4/7. The slope of any line parallel is the same. Okay, I want that same slope. So I'm going to use this slope, but this ordered pair, to write the equation of the line parallel to this one, but that passes through this point. So let's see what that looks like. I've got a slope, I've got an ordered pair, y minus 10 equals negative 4/7 x minus 5. Okay, so y minus 10 equals negative 4/7 x plus 20/7. And if I add 10 to both sides, That's the same as adding 70/7. So y is going to equal negative 4/7 x plus 70 plus 20 is 90/7. Okay? This is the equation of the line that's parallel to the line that passes through those 2 points, but this parallel line also passes through that point. So if I plug a 5 in over here, I can plug a 10 in over here, and the left and right sides of the equation will be equal. Okay, so there was a bunch of stuff to do there. Hey, did I say parallel? I meant to say perpendicular. Will you do this problem now to find the equation of the line that's perpendicular to the line through those points, but this perpendicular line passes through 5/10? Now, we already had that equation of the line. Remember, it was negative 4/7 x plus 40/7. There, I'll give you the leg up. But I want the line that's perpendicular to this one, and I want that perpendicular line to pass through this point. So what do we know about the slopes of perpendicular lines? Well, I remember that the slopes of perpendicular lines are opposite reciprocals. So if our original line has a slope of negative 4/7, the perpendicular line would have a slope of what? That's right, negative, no, they're opposite reciprocals. I have to change the sign, just positive 7/4. So remember, we flip and we change the sign. Okay, if my original line had a slope of 2/3, my perpendicular line would be negative 3/2. And if my original line was negative 4, then my perpendicular would be positive 1/4. Okay, so I've got to flip and change the sign. Okay, I've got that perpendicular slope, positive 7/4. I still have to use this point and that slope to write the equation of the line. So y minus 10 equals 7/4 x minus 5. Y minus 10 therefore equals 7/4 x minus 35/4. If I add 10 to both sides, that's the same as adding 40/4. 40/4 minus 35/4 is 5/4. And so this line is perpendicular to this line, and this line passes through that point. Excellent. Okay, so now let's review our graphing and transformation graphing, both with our reference graphs and with some sort of generic f of x. And then after that, we'll take a look at a linear word problem, and then we'll be done with our review, and you can start your review worksheet. Okay, graph, and don't forget to use your transformations. I want to see you using transformations here. I don't want you using guess and check. I don't want you using a t-chart with a million values on it. I need you to be using your transformations. The directions on the quiz are going to say, using transformations, graph this function. I can't give you credit if you don't use transformations. Okay, so our first function is cube root 2x minus 4 plus 1. So I need to remember what are the reference points for the cube root of x. I need to remember the shape of cube root of x. Is this the shape of cube root of x? No, this is x to the third. Remember, cube root of x looks like that. So I've got to know not only the reference points, but also the shape. These have the same reference points, but they have two completely different shapes. Please make sure you invest a little time in making sure you're comfortable with these reference points and shapes. Okay, now how do we carry out these transformations? Well, I see this plus 1 here outside of the function, so I know that affects y values. I'm going to add 1 to all the y's. But here, inside the function, I see two transformations. Do I add 4 and divide by 2, or do I divide by 2 and add 4? Well, we know that inside is SADMEP. And so I need to take care of any adding and subtracting before I do any multiplying and dividing. So I'm going to, inside is opposite land. I'm going to add 4 to all the x's. And so my transition points will be 3, 0, 4, 1, 5, 2. And then I have to go back and do this last x transformation. I see multiply by 2. That means I need to divide all the x's by 2. So my final points are going to be 3 halves, 0, 2, 1, and 5 halves, 2. So I'm going to have 3 halves, 0. I'm going to have 2, 1. And I'm going to have 5 halves, 2. And there's our cube root graph. Okay? I hope you were comfortable with that. You know, it's one thing for me to be comfortable with it, but it's another for you. You're the one who has to take that 50-point quiz, so let's make sure you're comfortable with these. How about this one? Y equals negative absolute x plus 1 plus 4. What are the reference points that we need here? Well, just like y equals x squared, negative 1, 1, 0, 0, and 1, 1. Except we'll have a different shape passing through these points. I see one x transformation and two y transformations. So with the x transformation, inside is opposite land, I just have to subtract 1. But what about with these two y transformations? What's the order in which I do two y transformations? Outside is normal land, so we use PEMDAS. So I want to take care of any multiplying or dividing before I do any adding and subtracting. I have to multiply all the y's by negative 1. Okay, so if I multiply the y's by negative 1 and subtract 1 from all the x's, these are my transition points. Now, what about this last transformation? Well, it's outside the function, so I know it affects y's, and I do what I see, so I'm adding 4 to all the y values. This will then give me 2, 3, negative 1, 4, and 0, 3. Remember, it's not sufficient just to plot the points. I need to have the correct shape through those points. The correct shape is not a parabola. Don't draw a parabola. This is an absolute value function. It should look like this. Now, I will tell you that I have a number of students who plot the 3 points and say, Mr. Kuple, you made a mistake because I can't draw this through those 3 points. That's right, you can't. So that's not the answer. What is the answer? Well, look, you've got this negative out here. A negative outside the function flips the function upside down. So we should have this down-pointing absolute value with points at 0, 3, negative 2, 3, and negative 1, 4. Please remember, having the points off to the side and not labeled on the graph, I mark it wrong. Why? That's right. I've asked students in the past, show me this point on your graph, and they point over here. So that's wrong. Therefore, I need you to actually label the points on the graph. I apologize if previous math teachers haven't asked you to do that, but this one is requiring it so that you can get full credit, okay? All right, so we need to know our reference graphs and our transformations. Let's do one with all 4 transformations here, okay? Why don't you give this one a try and come back if you need help or when you're done and want to check your work. Okay, so my reference points here, negative 1, negative 1, 0, 0, 1, 1. And I see 2 y transformations, I follow PEMDAS. I see 2 x transformations, I follow SADMEP. So I'm going to subtract 1 from all the x's, but I'm going to multiply all the y's by 2. So my transition points will be negative 2, negative 2, negative 1, 0, 0, 2. But I'm not done yet. I still have two more transformations to do. This one tells me I'm supposed to divide all the x's by 3 because I see I'm multiplying by 3. And then here, outside of the function, I see minus 4 to the y's, I do minus 4 to the y's. So my final points then are negative 2/3, negative 6, negative 1/3, negative 4, and 0, negative 2. Remember, this is just a plain old x to the third. It's not been reflected anywhere. There's not a negative here. There's not a negative here. And so I'm going to be looking at this shape. This point, negative 2/3, negative 6. This point, the inflection point, negative 1/3, negative 4. And this point over here, 0, negative 2. Great. Well, I hope you're feeling comfortable with transformational graphing with our reference graphs, but what about with a generic function? Why don't we have a generic function like this one, negative 2, negative 2, 1, 4, 4, 0, and 5, 1. And so this is our graph of f of x. And I'd like you to graph a transformed version of that called g of x. And my transformations look like this. F of x plus 2 minus 3. Remember, these are the reference points for f of x. So you carry out these transformations on these points. So let's put those reference points down. Negative 2, negative 2, 1, 4, 4, 0, and 5, 1. And let's apply our transformations. What transformations do you see? I see this plus 2 inside the function, so I know that's going to affect x's. I have to do the opposite. I have to subtract 2 from the x's. What about this? Well, this is outside the function, so I know it affects the y's. I do what I see with y transformations, so I'm going to subtract 3. So where are my final points? Negative 4, negative 5, negative 1, 1, 2, negative 3, and 3, negative 2. And now I need to graph this function. Okay? So 1, 2, 3, 3, I need negative 4, I need negative 5, and positive 1. Okay, so negative 4, negative 5, that's going to live over here, and yes, I need to label that point. Then I have negative 1, positive 1, that's up here. I have 2, negative 3, and I have 3, negative 2. And so what does my graph look like? Doink, doink, doink. There's my transformed graph. This is g of x. G of x is a transformed version of f of x, shifted left 2 and down 3. If I take this graph and I move it left 2 and down 3, I get this picture. Okay, so I did that one. Why don't you do this one? With the same f of x. So that's negative 2, negative 2, 1, 4, 4, 0, and 5, 1. Will you please graph this g of x? This g of x is negative 2f of 3x plus 1 plus 4. Okay? All right. Go do it. I know you can. And besides, we only have linear word problem after this. So, hurry. Okay, so what do I see? I see reference points, -2, -2, 1, 4, 4, 0, and 5, 1. Excellent. And for transformations, I see 2 x transformations, and I also see 2 y transformations. So with the x's, remember, we do SADNet. So I'm going to have to subtract 1 and divide by 3. But with the y transformations, we do PEMDAS. I'm going to multiply, see that's -2 times f. I'm going to multiply all the y's by -2. And then later, I'll add 4. So my transition points are -3, +4, -1, -8, 3, 0, and 4, -2. And then I have to come back and do that second round of transformations. I need to divide the x's by 3. And I need to add 4 to all the y's. So I end up with -1, 8, -1/3, -4, 1, 4, and 4/3, 2. Okay, well, let's see about graphing this. I notice the x's go from -1 to a little bigger than 1, and I see a lot of thirds. So I'm going to make a scale of thirds. This is -3/3, there's -1/3, there's +1, and there's 4/3. Okay? I need these y values. So if this is 8 and 4 would be a little lower, and 2 would be half of that, and -4 would be this distance down here. Okay, -1, 8 lives over here, and -1/3, -4 lives here, 1, 4 lives here, and 4/3, 2 lives here. So then I connect the dots, doink, doink, doink. You must have the points labeled on the graph. You must show me your transformation work to get those points. Okay? All right. If you need more help with any of this, reach out, let me know. I'm very happy to help you with it. If you don't reach out and you need some help, I feel sad, because you're probably going to struggle on the quiz. And I want you to walk into our quizzes and tests feeling really confident, feeling like you're really good with this stuff. And that means that don't lie to yourself and think you do know it when you don't. And also, when you don't know it, you got to ask questions about it. Okay? Especially this year, since we're starting off in quarantine. Okay? All right. So your brother owes you $128. And he pays off at a rate of $4 per week. Part A, write a linear model for how much he owes. We'll call that y as a function of W weeks. Okay, so weeks will be our input, and our output, dollars owed, is going to be Y. Now, I hope you remember rate of change times the input variable plus the initial amount equals the ending amount. Okay? So we're trying to find that ending amount, y. The rate of change is 4. The input variable, is W for weeks, and the amount of money owed is 128. What's wrong with this equation? Well, let's see what happens. If I plug in a 1 week has gone by. 1 times 4 is 4, plus 128. So after 1 week, he owes you $132. But wait a minute, I thought he was paying you back. I thought the amount that he was owed should be decreasing. So when he pays you back at a rate of $4 per week, this is negative 4. This is negative 4. Now when we plug in a 1 times negative 4 is negative 4. Negative 4 plus 128 is not a bigger number, but 124. After 1 week, he paid you $4. He owes you 4 fewer dollars. He doesn't owe you 128 anymore. He owes you 124. So I need to think when I do these problems. Okay? I can't just put down that 4 as the rate of change times the input variable plus the initial amount, because I might not get what I'm looking for. Okay? So this is part A. Now, what about part B? How much does he owe you after 13 weeks? How much owed after 13 weeks? So that 13, does it go in for a W or does it go in for Y? Does it go in for how much he owes or how many weeks? Well, this is a number of weeks, and so I want to put it in for W. Y equals negative 4 times 13 plus 128. So negative 52 plus 128. That's going to be 76. After 13 weeks, he owes you $76. Okay? And then let's ask that last question. When will your brother finally be done paying me off or paying you off? As in, when does the amount owed equal 0? Okay, when does our function equal 0? Well, now we want to plug the 0 in not for weeks, but for y. 0 equals negative 4w plus 128. We want to know when the amount owed is 0, so we plug in 0 for the amount owed, and we solve this equation for w. I'm going to add 4w to both sides. 4w equals 128. And then, when I divide both sides by 4, I get w equals 32 weeks. It will take your brother 32 weeks to pay off his debt to you if he pays back $4 each week. Okay? All right. Why don't you give a try to the review worksheet that we have, Graphing Basics Review Worksheet. You'll find that in our Teams folder. And get yourself ready for our first big quiz. All right, I hope this was helpful. Reach out and let me know if you still have questions. Take care.